Back part now, and on the back, the main focus is looking at what happens to those parent functions. So as you see up here, I have all three parent functions that's going to be typical and come up consistently in Algebra 2. We have the linear parent function, and we have those transformations or parameters that happen that are applied to that linear parent function. So the main functions we're going to look at is either our m and b, that's what we're used to calling it, is an m and a b. Or in terms of this and consistency, we're going to look at a and k. If we're looking at a quadratic parent function, those parameters, when they're applied to a quadratic function, is a, h, and k. H can also be applied to a linear function, but it's not common. I'm not even going to stress y'all out with looking at an h when it's applied to a linear function. All right? But it can be applied to a linear function. It's just not going to have the square. And then when we look at an absolute value function, it looks almost identical to the way we looked at it in the quadratics, except for it's a, h, and k, and we have those absolute value bars. So what the purpose I'm writing this down is so we're going to go through actual behaviors of when we apply a to a linear, quadratic, or absolute value, when we apply k to linear, quadratic, or absolute value, or when we apply h value that's inside to a quadratic or absolute value. Those behaviors are going to be the same. They're not going to change just because it's a different graph. All right? So if you can memorize or actually go through and repeat and focus and learn, you're going to actually see the same behaviors are going to happen no matter what the parent function was. All right, so we're going to look at the a value first. We have an a value on all three graphs. The a value is always going to be a value that's going to be out in front, and it's going to be multiplied. We see here I'm multiplying a times x. I'm multiplying a times the quadratic function. I'm multiplying a times, because how do I know it's times? Because it's glued to it. It's in front of it and it's attached to those absolute value bars. So this is a number that I'm multiplying out in front. What happens to those graphs? All right, so I'm going to write it over here. If a is greater than 1, it's going to actually stretch it or compress it. And I'm going to explain to you what stretch and compress means. So think of me. If I'm a V-shaped graph or if I'm a U-shaped graph, I'm going to actually take this picture right here and I want to stretch it. So that means my A value has to be a number that's bigger than 1. What types of numbers are bigger than 1? 2, 5, 7, 13. All of those numbers are bigger than 1. So if the number in front of my function is greater than 1 and I'm multiplying it, it's going to actually stretch it. So stretching it means you're taking the ends of this V-shaped graph and I'm going to stretch it upward. So it's actually going to get more narrow. Think about us as humans. If we're stretching, I'm not just going to sit here like this. I'm actually going to stretch my arms upward. My arms are going to get closer. They're going to stretch. They're going to elongate. They're going to get longer. They're going to get more narrow. So that's what stretching means. I'm taking the outside of this. I'm taking the outside of this and I'm going to stretch it upward to where they're closer together. So it's going to get more narrow. So stretch means narrow. Now, if I'm compressing it, let's say I'm this V-shaped graph and I'm going to compress, I'm going to press it downward. So it's going to get wider. I'm getting more relaxed. So my V, instead of being a V up here, it's going to get more wider. It's going to get a little bit more flatter. So it's going to compress. That's what compresses means. So I'm going to put wider. All right, so stretch means it's going to get narrow or skinnier. Compress means it's going to get wider. It's going to be a wider looking graph. All right, now let's go back to our A value. If your A value is less than 1, but A is also greater than 0, that's where it actually compresses. And I wrote that on the wrong one. So I should have took it off there. And that's an M. I made a typo. But that's an M, compresses. So this means it's going to get wider. All right. Now, what types of numbers are less than 1 but greater than 0? Decimals, fractions, those types of numbers are less than 1, but they're also bigger than 0. So it's going to be a decimal or a fraction. All right. Those are the numbers that's going to compress. So that's what happens when our A value is being multiplied. I'm emphasizing that it's multiplied out in front of the function. Now let's go look at H. So our H values. So I'm going to switch colors on here. I'm going to go to red. So let's look at our H value. So your H value is going to shift your graph. I'm going to put shift, left, or right. So how do I know which way it's going to shift? We've talked about that in this class before. If it's inside, we see our H value is inside parentheses. We see our H value is inside absolute value bars. So as long as it's inside these bars or these restrictions, we're going to think the opposite. The graph is going to move left or right since I have absolute value to the left or right, or since I have parentheses to the left or right. But which way does it move? It moves in the opposite direction. So if I have a plus H, it's actually going to move it to the left. Minus H actually shifts it to the right. And the only way you're going to learn that, guys, is you have to keep going through and practicing and testing yourself. All right? So right here, like this is minus H. So whatever my H value is, like let's say H was 3 and it was minus 3, this graph is going to move to the right 3 units. And that's exactly what I would write down here. 3 units right, or move, shift 3 units right, or whatever you want to write it. All right? And then if H is a plus sign, so if this is a X plus H, or if it's an X plus H, it's going to move to the left that many units, H units. All right, the last one is the easiest one to remember. We're going to look at our K value. And K, it is what it is. So if K is going to move up or down, all right? If K is positive, it's going to move up. And if it's negative, it's going to move down. That's what I meant by it is what it is. So if this is a minus K, it's going to shift the graph down 5 units. If this is a plus 4, it's going to shift the graph up. It's going to take this V and move it up 4 units. The vertex is going to be at positive 4. Same thing with this parabola. That line is going to move up 4 units or down 4 units or whatever that number is. So that many units, K units. So I'm going to leave this up on the board for you guys to look at and kind of look at the notes and see if it kind of triggers your memory. But a lot of this, especially when I'm talking about quadratics, should be a very close connection with what we're doing with absolute value, guys. There's no difference. All right, so I'm going to give y'all a little test. We're just going to look at these because I know if I delete this off, then I'm not going to be able to put it back up here. So let's look at number 1. What parent function do we think number 1 came from? Linear, quadratic, or absolute value? Linear. Okay, so I'm going to write y equals x up here. So to y equals x, it added a minus 4. Would minus 4 be a h, a, or k? So y'all said it's a linear function. So what did I add to this linear parent function? I added a minus 4. Will minus 4 be a H, or K? K. It will be a K value. Good job. So if it's K, I'm going to go look at my notes over here on K. K is going to shift that line up or down. It says minus 4. So where's that line gonna move? Down what? Down 4. And that's all you have to put for me. Down 4 units. That's your answer. So we describe what translation would happen to that parent function by putting down 4 units. I understand that, guys. You don't have to write some big paragraph telling me what's going to happen. As long as you put down 4 units, that means you were able to look at that graph and tell me what was going on. All right, let's look at number 2. This is the last one I'm going to do with you. Number 2, did they give me an A, H, or K?
H.
A what?
H.
A H. They gave me an H. So I'm going to go over here and look at my notes for H. Where's H at? H is right here. On my notes for H, it says the graph should shift left or right. And the reason why the graph is going to shift left or right is because I have absolute values to the left and the right. And the H value is 5 on the inside of that. So now, can somebody figure out, based on those notes, it says if it's plus H, it's going to shift left. If it's minus H, it's going to shift right. Can somebody tell me where this graph is going to shift to?
To the left.
It's going to shift to the left. Good job. 5 units. So that's what I would put on my answer. Left, 5 units. All right, so I just did 2 of them with you. So 3, 4, 5, and 6 that are on this back page, you go and do the rest.
What numbers?
Okay. Thank you, Ms. Green.